morning. So today we are going to see the session 7. Okay, the first unit, session 7, the micro electrode. Okay, so the micro electrodes, the objective of this session is students can understand the different types of micro electrodes. Okay, what is micro is very smaller size. Okay, in mathematics the micro equal to 10 4 minus 6, very small. Okay, so up to the last session, we were studied, that is surface electrode, needle electrodes. Okay, so this is another one type, that is a micro electrode. So when compared to other two electrodes, these electrodes are very small in size. Okay, right. So we are going to study the micro electrode and its types. So terms and terminologies. So here we are going to see different terms. First one, shaft. Okay, so the shaft is that is excuse me. Okay, the shaft is the body of the electrode, that is consists of shaft. Okay, that is in the rounded shaped shaft. Then another one is chunk, SHANK, chunk. So that is the narrow part of cylinder. Okay, normally consider our LPG cylinder, the gas outlet, that is called as chunk. Okay, the narrow part of the cylinder, or cylinder forming a long narrow part. Okay, right. Then next one is a etching. A metal is coating with protective layer, drawing it with needle, and covering with acid to attack the part of the needle it has exposed. That is, a etching is one of the process that is used with the acids. Already I think you were studied in semiconductor manufacturing. Okay, it's in the semiconductor manufacturing, the transistors, some unwanted portions are etched by some hydrochloric acid. Same way in PCP manufacturing, the unwanted portions are removed by hydrochloric acid. Okay, so that is called etching. Okay, here the etching is, we are extending the metal. Okay, in narrow format. The next one is pipette. Pipette represent long cylindrical part with narrow mouth. Okay, that is a pipette, already you were used in chemistry lab. Okay, so these are the terms we are going to use here. First one, micro electrodes. What is the purpose of why we are using micro electrode? The purpose, so the main purpose is to measure the potential difference across cell membranes. Across cell membrane. Okay, right. So then across the cell membranes means we have to use two location. One location is within a cell, another one location is outside the cell. So we have to use two electrodes. One electrodes, that is an active electrode, that is present within the cell, and another one support electrode, that is present outside the cell. Okay, this is a membrane potential, the potential difference between cell membrane. Okay, actually the requirement of microelectrodes are small enough to be placed into cell. Okay, cell is very smaller size, we cannot see by our eyes. So the cell is very small, so the microelectrode is inserted into the cell, that is very smaller in size. Okay, then strong enough to penetrate the cell membrane. So the microelectrode diameter is very small, in the range of microns. So if you push or insert the electrode into cell, so it should be penetrate, it should have the capability to penetrate the cell membranes. Okay, so it should be very strong, so that they are using very strong metals. Okay, silver, then tungsten, then glass. Okay, right. Then diameter of microelectrode is 0.05 to 10 microns. Okay, 10 microns. Okay, then types, it is having three different types: solid metal, supported metal, glass, micro pipette. Okay, three different electrodes are going to study in this session. Okay, right. First one, metal micro electrodes or solid metal micro electrodes. So this is a diagram of the cross sectional view of micro electrode. So actually this is a lead wire. This wire is used to connect with the amplifier. Okay, right. Then this is a body of the electrode. So this is called supporting shaft. Okay, this is called supporting shaft. So this is the main shaft. Okay, then this is a narrow position of the microelectrode, that is called as chunk. Okay, so chunk is very narrow position. Okay, so actually here it is looking like a cylindrical shape. The cylindrical cylinder is extended into very narrow position, that is called chunk. Okay, then this is a open of the microelectrode. So here we are having conducting material, the tip of the microelectrode. So this cross line, that cross line indicates insulation. Okay, so insulation present all the area. Okay, not in the tip. Okay, and tip is not insulated. Okay, so the microelectrode is filled via some metal. Okay, inside you are having the metal. So the metal element, metal or the Ag, that means the silver or silver chloride, tungsten, etc. Okay, this is a cross-sectional view of metal microelectrodes. So it is a fine needle of strong metal. Okay, it is fine needle. Actually metal microelectrode is looking like a needle. Okay, it is a normal needle. So that is insulated with an appropriate insulator up to the tip. It is completely insulated, the tip only exposed. Okay, so it is made by electrolytic etching. Already I explained before in terms. So it is made by electrolytic etching. So the needle is extended. Okay, by using electrolytic etching process. Suitable metals for these microelectrodes are stainless steel. Okay, microelectrode is made by stainless steel, platinum, iridium alloy, then tungsten. Okay, right, these are the material used to manufacturing metal microelectrode. Then tungsten carbide is also used because it having very high strength. Okay, right. So tungsten carbide is also used. The etched metal needle is supported in a larger metallic shaft that can be insulated. So actually this is our metal needle. Actually it's a needle. This is a needle is supported with a large shaft. Okay, right. So the shaft is also insulated. The shaft connect the lead wire at the another side. Okay, this is the lead wire already told. So this lead wire is connect through the shaft. Okay, right. So microelectrode and supporting shaft are usually insulated. Okay, so the supporting shaft is also insulated, and the supporting shaft, actually this is a supporting shaft, this also insulated. Okay, right. The next one, metal supported microelectrodes. This is another one type. So here the metal supported microelectrode. Actually metal supported means here some metals are used for supporting purpose. Okay, actually here we are considered two things, one is glass and another one is a metal. Okay, it is divided into two types: metal inside the glass inside the metal. Okay, metal inside the glass and glass inside the metal. So we will see one by one. First one I want to say metal supported microelectrode. So two different metals or materials are used to make the supported metal microelectrode. Actually it is same as of the microelectrode. Here we are using two different material, that is one is metal, another one is a glass. Okay, glass is used for insulation purpose and it is also used for strengthening, for making strength. Okay, strong insulating material is used for giving basic support. Okay, that is a glass. Okay, it's giving a basic support. Then this is a cross sectional view of That is metal inside the glass, metal inside the glass. Okay, the diagram shows the metal filled glass micropipette. Already we are I think you were used the pipette in physics laboratory. Okay, right? The physics laboratory are used pipette for making some uh, actually we are making something that is lead. So it is a filling glass tube with metal that has been that has a melting point near the softening point and pulled to form narrow constriction. Constriction means the narrow part, that is a constriction. Okay, right? How it is made? Actually, first they are take one glass tube. Okay, then the glass tube is heated. Okay, then after that it is heated up to the melting point. Okay, right? Soft melting point. Okay, it is not like a liquid level, some flexible level. Okay, then after that this glass tube is extended. So when it is extended, it is looking like a narrow part. Okay, right? So that way they are making this pipette. Here the classes not only provide mechanical support but is also serve as insulation. Okay, the classes provide very good insulation. Okay, so the additive is metallic area. Okay, the tip is a metallic area, so that is act as a electrode. So the metallic or the metals used here is the silver or silver alloy or platinum. These are the metals are used here. Okay, iridium also used sometimes. Okay, so this is a basic concept. So here this electrode is fabricated based on some very simple method. First we are taking one glass tube. The glass tube is heated for some flexible level, and after that the glass is extended. Okay, so when it is extended, it provide very narrow tip. Okay, after extended we can fill the metal inside the glass. Okay, and the tip is only exposed. Okay, the tip is act as a electrode or conducting material. Okay, right? It will acquire the action potential from the cell. Okay, right? This is a one type, and the another one is glass inside metal. Glass is inside. Okay, this diagram shows the glass micropipette or probe coated with metal film. Okay, right? So here, see, this is a glass. Okay, this is glass. This is metal, that is acts as an electrode. Then over the metal, we are having another one coating, that is a insulation. Okay, here we are using metal film. Okay, so the solid glass rod or glass tube is drawn to form a micropipette. The solid glass in previous type, here we are using glass tube, but here we are using glass, solid glass rod. Okay, the glass rod is heated for some flexible level on the melting point. After that the solid rod is extended. Okay, it is looking like this center position. Actually the white color is a full glass. Okay, so it is looking like a pipette. Okay, looking like pipette, but there is no hollow. It is fully solid. Okay, there is no hollow place inside, so it is act as a pipette. Then this glass this not a glass tube, glass rod. Okay, then metal film is deposited over this glass. Okay, the metal film is deposited, this is act as a electrode. The metal film is deposited over this glass rod. Okay, then after that insulation layer is coated over this metal film. Insulation layer is coated over this metal film, just okay, just leaving the tip. Okay, the tip only exposed, remaining all the part are insulated. Okay, right? So with the metal film that is exposed, the metal film is only exposed, that is act as an active electrode. Okay, so this is a glass inside metal micro electrode. Okay, understand? So sender, yeah, in the sender we are having the one glass rod. The glass rod is heated. The glass rod after meeting the melting point, it is extended to small narrow portion. Okay, small narrow level. Then after that, over the glass rod we are making some metal film. The metal film acts as an electrode. Okay, so the metal is actually act as electrode. Over the electrode we can fill insulation layer. Okay, some insulation varnish or any other things we can make an insulation layer. So the insulation is completely all the place except the tip position, tip only exposed. Okay, it is act as an insulator. Okay, right. Next, class micro pipette. Okay, so this is a third type of micro electrode. So here how the class micro pipette is made we are going to see. Actually this is a uh, class micro pipette electrode. This is a class micro pipette electrode. This is a tip of the electrode. Okay, so inside we are having capillary. Okay, so the empty space, this empty space is filled by electrolyte gel. Here we are having gap. Okay, this is our electrode. Okay, this is a metal electrode. The metal electrode may be a silver or iron or tungsten, whatever may be. This metal electrode is connected with the lead wire. This is a lead wire. Okay, right. It is completely filled with electrolytic gel. The tip is also exposed. Okay, the action potential is recovered from the cell through this electrolytic gel. Okay, right. So 3m KCl potassium chloride is act as an electrolyte here. Okay, right. So how it is manufactured we will see one by one. First one, fabrication process. The glass micropipette electrode fabricated from glass capillaries. Okay, so glass capillary. uh, okay, so the fabrication process, the glass micropipette is electrode is fabricated from the glass capillary. Okay, glass capillary means that is a small glass rod with some narrow inner position. Okay, this is like looking like a glass tube, straight glass tube. So consider diagram, that is a glass capillary. It is the length of around 1 feet. Okay, 20-30 centimeter length. Okay, then it is fine for glass capillary, fine for very small bore, small gap capillary is there, then which is heated by the burner up to softening point. Okay, so this capillary is heated up to softening point by using a burner. Then it is stretched to produce a constriction. Constriction means that is a narrow position constriction. Okay, right. That is a fabrication process of first process. The first process is we are taking capillary tube, then heating by furnace, then we are extending the tube. It produce or narrow position, that is called constriction. Then second, see the diagram. Now the capillary narrowed through heating and stretching. Okay, a special device such as microelectrode puller used that heat and stretch glass capillary in uniform way to fabricate micropipettes. Okay, so the instrument is microelectrode puller. Okay, that is used to create this pipette. Okay, then stretched capillary structure are broken at the constriction to produce two pipette structure. Okay, the center position of the capillary tube, that means the narrow position of capillary tube is cut together into two pieces. Okay, the diameter of the order is 1 micrometer. So the narrow portion diameter is around 1 micrometer. Okay, very smaller diameter. Okay, right. So this is a capillary process. That's the second process. The next one is the third one, the final stage of the diagram. So above diagram shows the final structure of the glass pipette microelectrode. It is filled with electrolyte solution, that is potassium chloride KCl. Okay, so the capillary is empty space. At the narrow portion we are having a very smaller tip, that is in the range of micrometer thickness. Okay, right. So the empty portion, the cavity is filled with some electrolytic gel. The electrolytic gel is a potassium chloride. Okay, right. Then after that, on the back side of the capillary is connected with the electrode along with one cap. Okay, the gap is used to connect the lead wire with electrode. So the electrode may be silver wire or platinum steel. Platinum steel is also used. Platinum steel is also used. Okay, right. So this is a fabrication process of micropipette electrode. Okay, so this electrode is entirely different. Here it is completely metal, sorry, completely glass material. So in the center position we are having a electrode. The electrode is contact with cell through electrolytic gel. Okay, so this electrode is very smaller in diameter. Okay, that is called as micropipette electrode. Okay, then the electrical properties of microelectrodes. This is a general electrical properties of microelectrodes. So all the microelectrodes are insulated by some insulator. Okay, so if you are having an insulator, it is act as a capacitor. Okay, so that is a capacitor. See, this is the central black line is a electrode or metal rod. Okay, this is act as electrode. Over the electrode you are having the insulation. The insulation act as a capacitor. Okay, that is CD capacitor. So this is a cell. This is one cell. So the outer line, this line indicates cell membrane. Okay, cell membranes. So the cell membranes separate the another cell. Okay, so it's a separation of one cell. Okay, so this cell membranes act as a non-conducting material. Okay, so it is also produce the charge, I mean charge layers. So outside the cell we are having the positive charge, inside the cell we are having the negative charge. Okay, so this is a nucleus. N is a nucleus. So this is main electrode or active electrode that is inserted within a cell. Okay, we are going to measure potential difference between cell membrane. Okay, so this is cell membrane. So this is inside the, we are inside the cell we are having active electrode, and outside the cell we are using a reference electrode. This is a reference electrode outside the cell. So by using the two cell, that means as two electrode, that is A and B, we can measure the potential difference between the cell inside the cell and outside the cell, that is called cell membrane. Okay, right. Then this is a equivalent circuit. So we are having insulation. The insulation is considered as a capacitance. Okay, right. Then this is a final insulation equivalent circuit. So here we are having the action potential. Okay, membrane and action potential. So that is considered as a voltage source. This is connected with the resistor. There is a resistor is a electrode resistance. This is a capacitance. Okay, right. Then that is connected with the point A. Okay, then other one is a reference electrode. The reference electrode is actually outside the cell. Okay, so that is connected with the P. That is the equivalent circuit of the micro electrode, metal micro electrodes. Okay, then here the microelectrode tip is placed within a cell. Okay, use metal electrode plus insulation that shows high impedance. Okay, then the amplifier, negative capacitance amplifier. The amplifier is a negative capacitance amplifier used. Okay, so this is the electrical properties of microelectrode. Okay, so before seeing the outcome, we have to see one video. Okay, how to manufacture, that is, oh no, please. Okay, we are going to see one small video how to manufacture the micro electrode. Okay, let's see.
Will instruct you on the preparation and care of an intracellular electrode and electrode holder. First, we will show you how to make an electrode. Take a capillary tube, push on the silver knobs to bring the wheels together, and set the brake. The brake is located in the lower right-hand corner. Make sure the knobs are loose, and then place the capillary tube in the slot shown here. Tighten the knobs to hold the capillary tube in place. They cannot be too tight. Release the brake while holding one of the knobs. Make sure the wheels cannot slip. close the electrode puller. Use the auto button to turn on the heating element. It should take approximately 7 seconds to pull the electrodes. When the heating element shuts off, open the lid. 2 electrodes are now ready. Loosen the knob while holding the outside of the electrode to remove each one. Take one of the electrodes that you pulled and a syringe of 3 molar potassium chloride. Using a microfill needle attached to the syringe, fill the electrode. Make sure the needle goes all the way down to the bottom of the electrode and continue to fill as you pull the needle back out. This helps to limit air bubbles in the electrode. Bubbles are bad. Bubbles will happen. They are usually here and can be forced loose by gently flicking the electrode. Our electrode holders have a wire. Feed the wire into the dull end of the electrode. Make sure the electrode goes as far into the electrode holder as possible, and then tighten the holder to secure it. Remove the electrode and place it into the waste container. Take a syringe of DI water and a microfill needle. Insert the needle into the holder and flush it with DI water.